All right, so Unit 1, Day 6, we're going to be looking at special functions, and we're going to start to look at graphing special types of functions. We're going to start with piecewise. Piecewise functions are any function that is defined on different intervals. All right, so you see three graphs here. Those are all examples of a piecewise function. They all have different rules depending on what interval of the domain you are using. So if you look at example 1, we have f of x is equal to x minus 4 for all x's less than or equal to 1, and f of x is equal to 2x for all x's greater than 1. That means that everything from 1 and to the left follows x minus 4, and everything to the right of 1 follows 2x. So I think the easiest way to graph a piecewise function is by making a table of values for each piece of the function. So we have a table for our x minus 4 rule, and we have a table for our 2x rule. And so we're going to have an x column, y column. Same over here. Now, I know that the biggest number that works for the first one is 1. I can't put anything into the function bigger than 1. So I just need to find some numbers that would be smaller than 1, like 0 and negative 1. Same thing with the second one. I know that the smallest number that works for that function is 1. So then I can put some bigger numbers there, like 2 and 3. All right. So now, what I'm going to do is just run each of those numbers through the respective functions. So negative 1, that's a negative 1. I'm going to run through the function. Negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. And 1 minus 4 is negative 3. So now I can take those points, negative 1, negative 5, 0, negative 4, 1, negative 3, and if you notice, this sign tells me less than or equal to, so at that endpoint I'm going to have a solid point. Now I can just follow that pattern and assume that that graph is going to continue on forever to the left. Same with the next column, 2x, so 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Now with this one, you'll notice the sign is just greater than, not greater than or equal to. So that means we need to have an open circle there at 1, 2. And then we can have a dot at 2, 4, and at 3, 6. And that'll continue on up like that. So like I said, that is the way I like to do it, because especially once we get to the more complicated piecewise functions that have like parabolas and absolute value and stuff like that, it makes it really neat and tidy. With linear, if they're just linear, then you do have some other options. I'll show you those. Right? So I'll leave the table there, but I'm going to erase the graph just so I can show you another way you can do it for a linear graph. Like I said, once you get to more complicated graphs, this isn't so easy anymore. But one way to do it is to start at the endpoint. So look at the 1, run 1 through the top function. 1 minus 4 is negative 3. Then look at the sign to see what kind of endpoint you're going to have. It's going to be closed. And then you can do the reverse of the slope. So reverse of the slope. So the slope is 1, which means I would go up 1 and to the right 1. But I need to go to the left, so I go down 1 and to the left 1. And I can keep doing that. And so the graph of that side looks like that. Then I look at the second rule. I see that 1 again is the endpoint, and it's a greater than sign, so it's going to be open. So 2 times 1 is 2. So at 1 comma 2, it's open. And then I use the slope of 2. Up 2 to the right 1. And again, we end up with the same graph. Maybe that was a little easier to get. That since they're both linear, it is pretty simple to graph. All right, there is a third way to do this, and some teachers teach this way, so I'll show you how to do that as well. This way, though, I think requires an extra step that I don't like to do, so I don't like to do it this way, but if you want to, I want to show it to you. In this way, we're going to graph the entire line. So we're going to graph x minus 4. So, of course, we look for the y-intercept, which is negative 4. Place a point there. Slope of 1. So it's going to go like this. And then it'll also go like this. And then we look at the second one. A line of 2x, so that of course goes to the origin, has a slope of 2. Oh. And that line would look like this. Now, we need to now respect the rules, so in order to do that, we're going to erase part of our line. Now, this is why I don't like it. It works really well on a digital surface like this, but on paper, sometimes it gets confusing. But we're going to, on the first line we drew, we're going to erase everything to the right of 1. So everything to the right of an x value of 1, we have to erase. And on the second line, we have to erase everything to the left of 1. So our line looks something like that. And now we need to go ahead and make sure we have the right endpoints. Solid circle there, open circle there. And we end up with the same lines again. So 3 different ways to do it. If you're cool with erasing, that might be the easiest. I like the table method myself. Some people just like to graph from the endpoint. It's really open to you. We'll do another one here. And again, I'm going to do the table for this one. So we've got 2 rules, negative 1/2 x minus 3. And then we have 3/2 x plus 1. Now, obviously, if there were 3 rules, we'd have 3 different tables. If there are 4 rules, we'd have 4 different tables. Just depends on how many rules there are. All right, so negative 4 is our breaking point. So that means negative 4 is going to go there and there. And since I know that it's greater than or equal to for the second one and just less than, this one is going to be the one with the open circle. So I'm going to put a circle around that negative 4 in the first rule to remind me that when I go to graph it, it gets an open circle. So now I need to find points to the left of negative 4. I'm going to pick points that are divisible by 2, since we're going to be multiplying by a half. So I'm going to pick negative 6 and negative 8, and then I'm going to pick not 6. I'm going to pick negative 2 and 0 for my other 2 points. All right, so run each of those through the function. Negative 1/2 times negative 8 is going to be 4. 4 minus 3. 4 minus 3 is 1. Negative 1/2 times negative 6 is 3. 3 minus 3 is 0. And negative 1/2 times negative 4 is 2. 2 minus 3 is negative 1. Then moving over, negative 4 times 3/2 is going to be negative 6. Negative 6 plus 1 is negative 5. 3/2 times negative 2 is going to be negative 3. And negative 3 plus 1 is negative 2. And then we have 3/2 times 0, of course, is 0. Oh, what did I do wrong here? Oh, and then 0 plus 1 is 1. There we go. Sorry. I was trying to do it in my head and screwed myself up. All right, negative 8, 1. Point there. Negative 6, 0. Point there. Negative 4, negative 1. And it's going to be an open circle. So then we have a graph that looks like that. And then we move on. Negative 4, negative 5. Closed circle. Negative 2, negative 2. And 0, 1. And of course we would continue on like that, up 3 and to the right 2. It would look like that. Again, you could have done the other two methods. That's the method I prefer. So moving on, analyze the key features of the piecewise function. So if we look at the domain of this is from negative infinity to positive infinity. There are no breaks because even though there are pieces, there's always at least one piece that is defined. There's never a hole, so there's no breaks. The range, start at the low end. The lowest this graph goes is to 0. And the highest this graph goes is to positive infinity. And again, there's no breaks in the action, so we don't need to account for any holes. X-intercept, there's only one, which is at 0, 0. Y-intercept is at the same point, 0, 0. Now, for x's, the set of x's where x is less than or equal to 0, the function is decreasing. So as I'm moving from left to right until I get to 0, it is getting smaller, closer to 0. For the x's between 1 and 2, the function is constant. And for x's greater than or equal to 2, the function is increasing. All right, so now we're going to look at step functions, a set of constant functions. The graph often resembles a staircase. Yeah, so step functions, the most common step function you're going to ever see is what we're going to look at right now, and that is the U.S. Postal Service. So, at the post office, and this is not current, I think these numbers are a little dated. Letters below 1 ounce cost 47 cents. Letters between 1 and 2 ounces cost 68 cents. And between 2 and 3 ounces, it costs 89 cents. And $1.10 if between 3 and 3.54 ounces. So, we're going to make a table and let x be the weight of the letter and c of x represent the cost. So the cost we know is for x's less than 0, or less than 1. All right, so x is less than 1, it's 47 cents. Now, for x's that are greater than or equal to 1, but less than 2, it's 68 cents. And then for x's between 2 or equal to 2 and less than 3, it's 89 cents. And then for x's between 3 and 3.54 ounces, it's $1.10. So, let's see here. Let's start with labeling the graph. So this will be weight, and that'll be in ounces. And this will be cost, and that'll be in dollars. Okay, so let's see. Ounces, we'll say 0.5, 1, 1.5, 2, 2.53, 3.54. All right, and then dollars, we'll go up by, I don't know, 15 cents. How about that? 60.75.9. Then we got $1.05, and then we've got $1.20, and that should be enough. All right, so for all packages less than an ounce, the cost is 47 cents, so just a little bit more than 45 cents. I'm going to put an open circle there because if it weighed an ounce, it's actually going to bump up a step to 68 cents. And that is going to be just a little past halfway between 60 and 75. All right, and then we have another level at 89 cents, which is almost to 90. And then our last level is at $1.10, which is just a little bit past $1.05. So there we go. And that should be an open circle. So I'll make sure that shows up as open. All right. So our domain and range. Our domain, of course, we can't go any lower than 0. 0, comma, I guess technically it could go up to infinity, but for this, what we've defined as the biggest is 3.54. And we actually don't know what happens if it weighs 3.54 or more, because it only goes up to that much. So we're going to put a parentheses there. It doesn't include anything more beyond that. And then the range, the lowest the range goes is 47 cents. And then we have a break. And then we have it defined at 68 cents. And then there's a break. So we're using those U symbols. Then it's defined again at 89 cents. Then there's a break. And then again at $1.10. And we're going to leave it just like that. All right, if you have any questions, be sure to shoot me a message on Canvas or send me an email. Hope you are able to complete your assignments without any problems.